Should we just wait and let Alpha Centauri get closer? Which will happen first, antimatter propulsion or fusion power? What are the consequences of crashing rockets into the ocean? And in Q&A Plus, can we detect the magnetic fields of planets being torn apart by black holes? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Gio Hondo, are there consequences for crashing a rocket in the ocean besides killing the local poor lobsters? I feel like the world should frown on this. I mean, there are obviously consequences, but it really depends on where the rocket crashes, what's on the rocket, and you have to put that into context with the other things that are happening on planet Earth. So when you have a rocket that is like, say, Starship, when Starship is landing in the Indian Ocean, in the middle of the Indian Ocean, it is thousands of meters deep, the water there. And so this thing is sinking down to the bottom of the ocean. Now it is going to release some fuel into the ocean wherever it crashes. But fuel is leaked into the ocean at all times that I'm sure a small marina somewhere on the west coast of Canada, all of the combined ships are leaking fuel that is the same or more than what you get out of a Starship crashing into the ocean. That, you know, if you're concerned about fuel leaks, boy, can we clean that up. Oil tankers that are heading off across the ocean carrying millions of gallons of oil. Like, just think about the terrible disasters that happen when these things crash. Even if they don't, I mean, they are leaking fuel into it. You can go out and look at the ocean and you can sometimes see a sheen of oil on the ocean, that there are pollutants in that ocean. So always you have to put it in context with the other things that are happening. You know, are we concerned about rockets crashing into the ocean? If we're concerned about pollutants, there are easier, quicker, bigger levers that we can pull on. Are we concerned about metal going into the ocean? Not really. In fact, you know, it appears that when, say, ships are sunk, these provide really interesting, useful habitats for sea life, that you get a restoration of sea life. And so a lot of the times they will take old ships, they will strip them, all of the toxic parts off of the ships, and then they'll sink them. And then you come back a couple of years later and the thing is covered by coral and fish have returned. And there's, you know, a lot of stuff that is going on. And then you can balance that with a number of ships that are going into, you know, and then the amount of garbage, the Great Pacific Garbage Patch, the amount of plastics that are just being dumped into the oceans by all of the world's rivers. And so I think it's really important when we see these kinds of things and we feel very frustrated by events that are happening. We look at this rocket crashing into the ocean, exploding, sinking into the water, and like, that felt wasteful. That felt bad. But that instinct should then be matched to some other instinct that says, I am concerned about the state of the planet's health. I'm concerned about the pollution that humanity is causing to the planet. I should investigate and contribute and think about how I can participate, or at least draw a light to the things that are causing damage to our planet, because there are things that human beings are doing right now. Methane leaks, obviously putting carbon emissions into the atmosphere that are causing all kinds of short-term and long-term damage to the planet and to life and to humanity's stability in the kind of climate that we had become accustomed to. And so I think you have to put these things into context. Rockets definitely release carbon dioxide when they launch, but there are tens of thousands of airplanes flying every single day. And so the amount of carbon dioxide that rockets release is a fraction of a fraction of a fraction of a percent compared to ship traffic, car traffic, plane traffic. That if you're concerned about these kinds of things, there are a lot of things that we should do that would allow us to reduce our impact on planet Earth. And that should be your trigger to say, oh yeah, I care about this. Let me look into how I can encourage more transit in my city compared to people driving cars. Or I should vote for people who are looking to push more efficient fuel standards. There is 100 tons of debris from space raining down on planet Earth across the entire planet every single day. Just little bits of metal and rock coming from space and it's just raining down on the planet, across the entire planet. That is the background. And a lot of those are like on your roof, which is very cool. But so it's just like super important to put these kinds of concerns into context for what is the larger damage that humanity is doing to the planet, or really how humanity is risking itself. Gadzooks, do you think we might have to wait 5,000 years to send humans to Alpha Centauri when it will be a lot closer? Now, I don't know the exact orbital mechanics of the sun versus Alpha Centauri as they move around the Milky Way, but all of the stars are moving relative to each other, and that there were times in the past, and not a long time in the past, like say 50,000 years ago, when a star came within 1 light year of the sun, which is kind of crazy. Like we would look up and we would see this very, very bright star that was very close to us. And there are times in the past and in the future when stars will come within 1/10 of a light year of us, that it will be by far the most bright, I guess the second brightest star, if you're going to be, really particular about this. But yeah, that the configuration of the stars that we see in the sky are just an example of our current time. You go forward 100,000 years, a couple 100,000 years, and the Big Dipper no longer looks recognizable, which I find a mind-blowing idea already. So let's think about what it's going to take to be able to go to it, like say Alpha Centauri. And, science fiction has filled our heads with the idea that we're just a couple of decades away from us pulling together everybody and putting them on an interstellar mission. The year is 2280 and the mining ship has arrived at Alpha Centauri or whatever. And the reality is that it's just like the amount of energy involved, the technology required to keep humans alive for that kind of a duration is ludicrous and beyond our capabilities. And one of the most interesting papers that I've read on this subject is called the weight calculation. The gist is that, let's say you send a colony ship to Alpha Centauri, and then 10 years later, the technology is much better. And so now you send a new colony ship to Alpha Centauri and it passes the first colony ship, and they look through the window and the people on the first one are very sad because now they left earlier. Now they have a longer trip to get to Alpha Centauri while the other ship is already on its way and it's going to arrive there earlier. And then 10 years later, you've got new propulsion technology and a new colony ship goes and it passes the first and the second. Well, there is a time that you have to wait where you're not going to pass the other. Like that is like the best strategy is to just wait until the technology has matured to the point that you can reach this other star system. So there is going to be a natural number, there will be a year. If you put in all your estimates and your assumptions, you'll be able to calculate the year when humanity is likely to have the technology to be able to send a colony ship to Alpha Centauri. And I don't know what that number is, right? It could be 500 years from now. It could be 10,000 years from now. It will be some number. So that's sort of like the first thing to kind of keep in your brain. And that the closer the stars are, the less time, the less technology, the sooner we could attempt that various idea. And so one of the really interesting ideas, if you sort of go back to the Fermi paradox, when Enrico Fermi was looking at the Milky Way and thinking about, the universe is big and it's old and life on Earth formed as soon as it could, and it's feasible. The laws of physics don't prevent us from going to other star systems. Where is everybody? That maybe it would take you 10 million years to be able to send a spacecraft to every star system in the entire Milky Way. And yet we don't see the exploring von Neumann probes coming from all of these other civilizations. But recently, there was a paper, David Kipping worked on it, and Adam Frank and some other people said, well, if you consider the close flybys of all of these stars, that instead of you saying, we're just going to brute force go from this star to the next two stars to the next two stars. Instead, if you just wait 10,000 years, 50,000 years, you just wait on average for stars to get extremely close, and then you just leapfrog to the next star, it actually doesn't add very much time to your total exploration time. That the civilization that brute forces and it spends all the money gets the entire galaxy explored, colonized in 10 million years. But the one that waits for all of the close flybys of the stars, it only takes them a couple of extra million years. Like, it is not a lot. And they save 90% of their fuel because they did this in the most efficient way. So there's a lot to be said for looking at the kinematics of the stars in the Milky Way and then timing your expansion, as long as you're patient, right? Timing your expansion to match when all of the pathways are as quick and as low energy as possible. And that still gets you to a fully explored or colonized galaxy in a realistically reasonable amount of time, which makes the Fermi paradox even weirder. That for all the people who say we can never travel to Alpha Centauri, well, and then you say, well, what if Alpha Centauri was 1/10 of its distance? What if it was only, 0.4 light years? What if it was 0.04 light years away? Could we get there then? And that the longer you're willing to wait, the closer stars will come on average. That's crazy. And yet, that is what's happening out there in the Milky Way. It's time to shout out all the new $5 patrons and above. Ben Walker, David IDG, Mike Hutley, Mark Sproul, Tyler Holt, Chris Lucero, Beakley, Tino Cole, Austin Weber, and Gary. Join the club at patreon.com/universe today. Fermi's proponent, antimatter power first or fusion? I think we're going to see fusion power first. Now, the joke, of course, is that fusion power is always 30 years away. But at this point, we are seeing the development of a large tokamak facility in Europe, the ITER facility, and it is, a decade away from attempting its first fusion. They're going to start with deuterium fusion or tritium fusion, and then they're going to move their way up as they get better and better at the technology. And this is a serious attempt. This is okay, we think we understand the fundamentals of fusion. Let's spend the money to build a giant machine that should be able to create sustained fusion. But you've got other work. The Germans are doing this. The Chinese are doing this. You're seeing better and better fusion that's going on. And so I think we're going to see the synthesis of all of this. And that maybe 30 years from now, somebody will demonstrate sustained fusion that produces more energy than it takes in. And, we saw a couple of years ago, the National Ignition Facility in the United States test laser fusion, where they fired a whole bunch of lasers at a little pellet of hydrogen fuel, and they were able to generate more power out of the fuel than they put into it. But that didn't account for all of the lasers that they had to do. So that was not cost effective, while these tokamaks may very well get to a place where you're just getting cost effective fusion that is coming out of the facility. And then the market forces will probably work to bring those costs down and make it more efficient and make it more reliable and so on and so forth. So antimatter is actually not a form of energy generation. Antimatter is really a form of energy storage. That antimatter is the most efficient method of generating energy that we know of. You take matter, you take antimatter, you touch them together, you get pure gamma radiation coming off of that annihilation. And so if you can go and take a giant particle accelerator, generate antimatter, somehow capture it, store it in some location, then when you need a very compact form of energy, you take your antimatter, you just find some local matter, you put them together, tons of energy, you've done that. And the consequences of this, and I think the question you're really asking is, we're going to have fusion rockets or we're going to have antimatter rockets. And we're still probably going to have fusion rockets before, because we are already seeing some really interesting ideas for fusion rockets, direct fusion rockets, where it's it's a halfway point between a thermonuclear weapon that is being detonated in some level of control versus an actual controlled fusion reactor that's pumping out electricity, right? Like we're on the spectrum in between those. And this technology is maturing. Some people have made some really interesting advances. I've reported on them. NIAC has been funding various fusion engine concepts. There's a lot of companies that are working on that. If you do search on my channel for fusion rocket, you will probably be able to watch a bunch of interviews. People are working on antimatter storage. CERN recently announced that they had gathered a bunch of antimatter, put it on a truck, moved the truck around the CERN facility, put it back into a different system for doing testing, and they were able to hang on to it. And so antimatter containment is coming along, but it is a battery. Antimatter is not like, let's just harness the antimatter that's everywhere. No, it is, let's use fusion or fission or solar power to generate antimatter, and then let's store it so that we can then use it in a compact form later on. But I think we are absolutely going to see fusion come first, then antimatter. Antimatter is great. Antimatter is the most compact form. It is probably the system that gets us to the stars. That there's almost like, apart from a light sail, there's really nothing that has the energy density that is required to be able to accelerate a rocket to another star system than antimatter. And so we will need to master it before we can make an attempt to send spacecraft to other star systems. I think laser sails get us probes to do fly-throughs of the star systems. Antimatter rockets give us maneuverability, carrying crew, passengers, colony ships, DNA factories, things like that. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, can we detect the magnetic fields of planets being torn apart by black holes? I'll put a link in the show notes. All right, those are all of the questions that we had this episode. Thank you everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. I'm going to go on a rant about SpaceX coverage, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Carradine, Chuck Hawkins, Commander Balak, Dark Finga, David Gilton, and David Matz, Enthralled Reading and Math for Toddlers, Eric Lindstrom, Evan.pro, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Marcel Smits, Michael Purcell, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Filemonley, Team 49, Telescopes Canada, Vlad Zeppelin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I got this comment from Bass Finnis. This is swiftly turning into a Musk fanboy space. Thanks for the comment, Bass Finnis. Now, I'm not sure whether you were talking about me, my reporting, or you were talking about the comments that other people were making on the video. And so I'm going to sort of err on the side of caution on this in my response, but still, often when I make various comments and editorialize or report on stuff about SpaceX, I get accused of being a Musk hater, of being a SpaceX hater, and not being excited enough about what SpaceX is doing and their dramatic contribution to human spaceflight. But of course, in the same videos, I will also get the opposite, which is that people are saying that I am too excited about what SpaceX is doing and too much of a fanboy. And so, I always take that as a badge of honor when both people are accusing me of being overly hostile to SpaceX, as well as being overly excited and too much of a fanboy. I must be sort of walking some kind of neutral line right in between. And obviously, as a space journalist, it is a very complicated time to report on what's happening with SpaceX. And just like space exploration in general, it is jumped out of being purely just, hey, space is cool, here's the things that are happening, into a more political forum. And there's a White House administration, and the White House is setting the directives for what they want NASA to do. There is a Congress and the Senate that are pushing back against the priorities from the White House. You have billionaires like Jeff Bezos and Elon Musk and others who are influencing the conversation as they develop their own space companies, and that there is this layer of stories on top of that people are sort of bringing this perspective to what these companies are doing. On the one hand, people see them as being sort of crusaders for human exploration of the cosmos, and then on the other hand, people see them as being the billionaire class, the oligarchs that are stealing the money from regular people. And the reality is this sort of complex mush that's in between. And so my job as a space journalist, or as a journalist in general, is to try desperately to report on the objective facts that are happening. You cannot just say, la la la, SpaceX doesn't exist, nothing is happening, right? They are involved in launching communication satellites, in launching NASA missions, and of course the development of whatever is the next fully reusable two-stage rocket, or not, if that doesn't fail. They're responsible for developing the landing system for the upcoming Artemis 4 mission. They're supposed to demonstrate reusability and reuse and refueling in space. This is something that they are ostensibly working towards. We can see the reality, which is that rockets land either at their launch pads, they land on drones out in the ocean. We're watching them getting caught by Mechazilla. Some people say that that's just ridiculous. It's not going to go anywhere. Other people think that the colonization of the Milky Way is right around the corner. My job is to report on the things that actually happen. I really try to minimize as much of that kind of political influence. You can't not talk about it, but I really try to minimize it. I barely say the names of the leaders who run these companies, and I focus on the activities of the companies themselves, the missions they're launching, and the contribution made by the engineers that work at these various companies, and the overlap between what NASA is doing with both Blue Origin and SpaceX. But I know that a lot of people that have emotions that are mixed up into this. I can't not report on it. And I need to be very careful that I don't overly report on it in ways that are overly enthusiastic and excited about things that we watch timelines stretch out. We watch rockets explode. We know the challenges. We watch money being lost by gigantic space conglomerates. So it is a very complicated world. And what I can guarantee to you is that I will just continue to report on what I see, on what happens, on the concrete things that are done. And some of those things will be good for humanity. Some of those things are going to be bad for humanity. That is what news does. That is journalism. And together, we will be able to look back in a couple of decades and be able to trace the path of what actually happened, not how we were feeling about it in the moment. All right. We'll see you next time.